This is a total production. Hello, Chem Minions. Alright, so total here. This will be our first of 5 practice videos for chapter 3. So before we get into like functional groups, one of the things we want to understand with some of these functional groups is first we need to look at just a carbon structure, carbon-hydrogen structure, and determine if that carbon is primary, secondary, tertiary, or quaternary. And really, we just look at an individual carbon and we see how many other carbons it's bound to. That's all we have to do. So even though all of these are the same, what I'm going to do is I'm just going to put a dot for all of them that are primary. So I'm looking for a carbon that's only bound to one other carbon. And so that's easy. That would be here, right? That carbon's only bound to one other. Right here, that one's only bound to one other. And then these 3, right? Those 3 carbons. So there's 5 of them for this structure. Then if we go and look at the secondary options, we're looking at carbons that are only bound to 2 other carbons. So that would be here, right? That carbon has 1, 2 bonds. That would be here, here, and here. All right, so this has 4 secondary carbons. Next, we would look for tertiary, so a carbon that's bound to 3 others. So that would be right here, right? That carbon has 1, 2, 3 bonds to it. And then here, that carbon has 1, 2, 3, 4 bonds. So there's only 2 tertiary carbons. And then this guy is going to have 4, so that would be this. That is the only carbon that has 4 other carbons bound to it. Alright, now in looking at the next set, so all these are the same structure again, but as we look, one thing to pay attention to here, any of these that have the double bonds, we're not going to classify those as primary, secondary, tertiary, or quaternary. These are a special type. So all of these in this ring are automatically off the table. Okay, because they all have double bonds, and so we're not gonna mark any of these for primary, secondary, tertiary, or quaternary. So then for primary, we're looking at the rest of the stuff. So that would be this carbon here. It's only bound to one other carbon. This carbon here is only bound to one other carbon, and that one there. So there's 3 primary carbons. For secondary carbons, we're gonna have 1, 2. So those 2 there. And then these 3 right here, those 3 are only bound to 2 carbons. And that should be it. And then next we've got a tertiary. So that would be this one right here. Okay, we only have 1 tertiary. And then over here we don't have any quaternary, so there aren't any. So I'm just going to put an X on it because there aren't any quaternary carbons. All right, and then so the same thing kind of applies here. When you see pi bonds on your carbon, you're going to ignore that. So we're not going to pay attention to that carbon at all. So for primary, remember it's just bound to 1 other carbon. So we would look here, 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 and here. All right. For secondary, looking at 2 other carbons. So that would be this guy here and this guy here. They're each only singly bound to 2 carbons. All right, and then tertiary would be this one. All right, it's got 1, 2, 3 carbons bound to it. And then quaternary, that would be this guy right here. Okay, it's got 1, 2, 3, 4 different carbons bound to it in the form of single bonds. Alright, and then to finish up, this next part is all about DOU. I don't know what's wrong with you. But anyway, DOU, that's degree of unsaturation. So a DOU of 1 could be either 1 ring or 1 pi bond. So that's what you need to look at with all these structures. Count the number of pi bonds and count the number of rings. So here this guy has 1, 2 rings, and then it has 1, 2, 3, 4, 5, 6. Has 6 pi bonds. So it has a DOU of 8. 6 plus 2. That's what I did. Alright, this guy has 2 rings. And then it has 1, 2, 3, 4, 5, 6, 7. And it has 7 pi bonds. So that would be 7 plus 2, or 9. So this one has a DOU of 9. Alright, next up here. So this one was a little tricky. In particular, that group right there, this is an aldehyde that we learned about in this chapter for the first time. But an aldehyde looks like that. So the CHO is CHO like that. So this actually has one ring and it has 2 pi bonds, right? Because it's got one in the carbonyl here in the aldehyde, and then one there. That's just a regular alcohol functional group, so there's no pi bonds to worry about. So this has a DOU of 3. All right. This one down here, this one's a little tricky too in that it's condensed. So the nitriles have a triple bonded nitrogen. So this has no rings, but it has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 pi bonds. So it has a DOU equal to 8. All right. In this structure, it's got 1, 2, 3. It's got 3 rings. And then it's got 1, 2, 3 pi bonds. So it has a DOU of 6, right? 3 plus 3. All right, and then lastly, looking at this guy, we've got, that's just an ether functional group, so there's no pi bonds to worry about there. But this has 2 rings, and then for pi bonds, it's got 1, 2, 3, 4, 5. So it has 5 pi bonds also, 5 pi. So that would be 5 plus 2, or a DOU of 7. All right, so that's kind of the quick and dirty way to get the degree of unsaturation, or the DOU. All right, stay weird.